Okay, cool. Welcome everyone to the second part of the Sloss Talks. This is our speaker order, and I will kick us off this morning. My name is Mia, for those that don't know me, and I'm going to be talking about my research, which aims to disentangle some of the drivers of primary productivity in lakes in Greenland. And the motivation for this research comes from a phenomenon that Arctic researchers are calling Arctic greening, which is what happens when temperature warms, permafrost starts melting, soil starts developing, and lake systems start becoming more complex in their ecological structure and start becoming more protective. And while the drivers of these processes are well defined, one unresolved debate that I focused on is whether lake productivity is primarily driven by catchment processes or climate processes in any given location. And I think the reason why this debate is so hard to deconvolve is that even though paleolimnology can be a really useful tool in trying to understand these processes, a major problem that we run into is that different primary producers respond differently to these changes in the same lake system. So here's an example from South Greenland, where we see within a lake down a sedimentary record, diatoms and salt-bodied algae not reacting to these stresses in tandem with each other. And oftentimes having lags. So I think that in order to resolve this debate, we need higher resolution, more specific, taxonomically specific methods. So my biomarker of choice are sedimentary pigments, and pigments are organic compounds, complex organic compounds that are made by organisms that photosynthesize. And you can use them kind of how I've designated here. And you identify them using HPLC mass spectrometry, which is what I'll be doing at MCirc and the chemistry department at Northwestern. And so here's like my leading question for this research is, are the relative influences of temperature, climate, or nutrient influx, catchment driven, consistent across millennial timescales, which are the best timescales for sedimentary pigments, and also across the diversity, ecological diversity of different primary producers in the watershed. So I'll just end with what I did this summer. I went to Greenland. It was amazing. I was up in the north of Greenland on the Tuccillo Air Base, which is a US air base. And I collected a bunch of modern materials like lake water, filtered them for modern microorganisms living in the lakes, and also some other aquatic and terrestrial plants. That's a really gross cyanobacteria I found. And then the South Greenland team recovered these amazing sedimentary records from lakes, in addition to some of the surrounding organisms. So this is a core that I just split last week. I'm working on the chronology for it right now. It's beautiful. Yeah, that's the one question. And that's a muskox. That was awesome. They're really cute. Yeah.
And your pigments range from ketones to enzymatic proteins.
Yeah.
Can you say anything about the relative degrees of preservation of the different types?
Yeah, that's a great question. So the preservation of pigments is what makes them the hardest. Like that's the biggest problem in identifying them. Obviously, your observation is totally correct. They break up and break down in different ways. We actually kind of understand how this happens and what their diagenetic compound or products are. But the reason why it's been so hard historically for people to identify them is because we haven't been using a mass-based method that like measures the masses of those fragments that we know that we should expect to find. And so actually using mass spectrometry, the HPLC mass spectrometry is like a brand new method. Most people use HPLC combined with some like spectral detector that measures absorbance. And that won't actually pick up on some of the compounds that deconjugate in their conjugated double bond system. So those are like colorless compounds that don't absorb light. And so that's the motivation for using that specific method because of the diagenetic processes.